Hi, I'm Hein, and this week we will talk about the memory device, especially DRAM. DRAM is the dynamic random access memory. The random access memory means we can access any position when we write or read the data. As we studied before, the DRAM is consisted with two components, one transistor and one capacitor. So we can call it 1T, 1C structure. As I said before, DRAM used the storage capacitor, and the capacitor lose charge. It means it discharges naturally and automatically, so we need to refresh regularly when we use DRAM. Because the process technology are improved, and so the density of the transistor are increased or so we can make more and more transistor in same cost. The DRAM cost is also decreased per unit data size. When we make DRAM, we can choose two types. The first type is trench type. The second type is stack type. Trench type means we put the capacitor like a structure of STI or DTI, the trench isolations. When we use the trench type, we make the capacitor first and we process for transistor. So we can have the high summer budget because we make the transistor first and the capacitor first and transistor. But when we use stack type is the structure we make the transistor first and put the capacitor on the transistor. So we make the transistor first and make the make the capacitor. So when we make a capacitor, we have to consider the summer budget of the transistor, because if we use the too high temperature, it can cause the ruin of the junction of the transistor. But it is not that much important nowadays, because in DRAM capacitor, it is very important to have the enough sensing margin, or it means you have too high capacitance. So nowadays we use the high K materials for the capacitor, so it means it is difficult to use high temperature when we make a capacitor process, and it also means it is difficult to have the high summer budget when in capacitor process. When we make DRAM, it is also important to have a good layout. As we know, the transistor have the source drain and the gates area, but when we put the structure like this, it is cause the waste of the area, because we can use this area in beside of the source drain. So we flip the one structure like this, so we can make a common source structure. If we use the common source structure, we can decrease the waste of the area, because we only make a common source, not two source. Like this, we can decrease the total area of the DRAM. This structure is called 8F square. The F means the feature size, and we need 4 feature size in the lateral side and 2 feature size for the vertical size. So it equals 8F square. But in 8F squared structure, we need the passing gate like this line. This passing gate is need for to pass one higher row to access the next row, the downstairs. But to increase the area of the DRAM, we need to change. We need to waste this no, we need to waste this passing line. So to put the DRAM cells optimally, we use the 6F square structure. 6F square structure is the structure which don't use the passing gate. So to defend the interference with the higher row and the lower row, we have to tilt the DRAM cells like this. By changing the degree of the DRAMs, we can decrease the total area of the DRAM structure. And next, when we decrease the transistor size, the LCE problems can occur in DRAM also. So to improve the LCE problems, we use the cell array transistor, which is called CAT. So this is the recessed CAT, means the recess the channel like this shape, so we can have the more long gate lengths. And it was not enough, so we can recess the gate and make a board shape like this. So this SR CAT. Like this, the single gate structure was improved to improve the LC problem, but it was not enough. So nowadays we also use the multi-gate structure like logic device. In DRAM, the famous thing is Setter structure, Setter fin. We recess the gate like this Setter shape and put the gate on it, put a word line on it. By making this structure, we can increase the surface which contact with the word line, and it means we can well control the channel. Today we learned about DRAM structure and DRAM processes for nowadays. Thank you for listening this week's review.